Okay, so on Friday, we did limits looking at graphs and tables. So now we're just going to kind of build upon that. So take a second and see if you can answer these first few questions and come up with some rules. So pause the video and think about it. All right, so use the graph to evaluate the limit statement. So we decided that on when we looked at this limit, so to evaluate this limit as x approaches 2 of this, so as x approaches 2, so I have to show that it's the same value from the left and the same value from the right. So what is that? So the limit as x approaches 2 of 1 is going to be a 1. All right. Same thing over here. So the limit as x approaches 2 here. So here's my 2. So as I go up to 2, and from the left and from the right, it's going to be equal to a 2. All right, so about this one, the limit as x approaches 2 of x squared. So for this x squared graph, so as I'm approaching 2, so it's going to be equal to a 4. And then what about this one? So compared to number 3, how did this limit change? So 3x squared, so as x approaches 2, so 1, 2, so I'm gonna keep going way up here, so it's gonna be 12. Okay, so what did I do? So I took the limit, right? So I took the limit as x approaches 2 of x squared, and then I just multiplied it by 3. Okay, so I took 3 times 4 and it gave me a 12. All right, so so instead of just looking at the graph, what could I have done to find this limit? So I could have used direct substitution. Okay, just could have plugged it in. All right, so what about this one? So evaluating the limit statement. Okay, so the limit as x squared, x approaches 2 of x squared plus a 1. So, so I'm going to 2. So as I go up here to 2, the value is going to be a 5. So how does this compare to number 1 and number 3? So let's look at number 1 and number 3. So this is the limit as x approaches 2 of 1, and then this one is your x squared. So what does it look like I'm doing to those two things? Looks like I'm kind of adding those two things together, right? So the limit as x approaches 2 of x squared, and then I'm going to add it to the limit as x approaches 2 of 1. Good. All right, so how about this one? Limit as x approaches 2 of x cubed. So as I approach 2, so what is it? So it's going to be an 8. So how do these two things compare from number 2 and number 3? So it looks like I'm just multiplying those two things together, right? So the limit as x approaches 2 of just the x, and then times the limit as x approaches 2 of x squared. Okay. So what about this one? So here I'm taking two functions and I want to find the compositions here. So f of g of x. So remember that means that I'm going to plug g of x in for f. So it's going to look like this. So plug in g of x. So it's going to be x plus 2, all of that squared, plus a 1. All right, so if I found the limit as x approaches 1 of that, so the limit as x approaches 1 of x plus 2 squared plus a 1. So what's that going to be? 10? All right. So how do you find the limit as x approaches 1 of just g of x? So what's that going to be? So it's 1 plus a 2, which is a 3. So I'm going to take this answer for part C and input it into f of x. So how does this result compare? So if I'm going to plug that in, so that's 3 squared plus a 1. So what happens? Those are the same, because all you're doing is taking the limit of this one and then plugging that value, that y value, in there, because it is a composition of functions together. Okay. All right, so let's talk about some basic limit laws that we just went through. So these are kind of important. I'm going to say this. C, when I do C and B, those are going to be constants. Okay, so the limit as x approaches some C of some constant B, that's just going to be a B. All right, the limit as x approaches C of any function added or subtracted to another function is just going to be the limit of, as x approaches C, of that first function, so f of x. So I can split it up like this. So this is just like that number 6 that we were going through. If we have two functions multiplied together, so same thing can apply here. So we can say the limit as x approaches C of f of x times, the limit as x approaches C of g of x. Same thing with division, so the limit as x approaches C of any division here. As long as your g of C is not equal to 0, we can separate that as the limit as x approaches C of f of x all over the limit as x approaches C of g of x. And as long as this one right here does not equal 0, we're good. Okay. If we just have some x values, so the limit as x approaches C of x, so we're just going to direct substitution that in, so that's just going to be a C. And then our composition, so the limit as x approaches C of a composite function. So that's just going to be the function evaluated at the limit as x approaches C of the g of x function. So you're going to take the limit of the inside function, and then whatever you get there, you're going to plug it into your f. Okay. All right, so pause the video, take a second, and answer these bottom questions. So questions 1 and 2. All right, so here, direct substitution. So we can plug in 2 everywhere we see an x. So when we simplify that, we'll get a 15 there. Limit as x approaches pi over 2 of sine x. So direct substitution just says I'm going to say sine of pi over 2, which is just a 1. And then here the limit as x approaches 3 of e to the x, which is just going to be e to the 3. All right, so we're going to use, for this one, we're going to use the graphs and also just our normal, our basic limit laws here. So the limit as x approaches 2 of f of x plus g of x. So the limit evaluated at f of x, so the limit of, so we're going to look at the f function. So as I approach 2, that's going to be a 2. The limit as x approaches 2 of g of x, so as I approach 2 here of g of x, that's going to be what, a negative 3. So then add those two things together, so it's going to be a negative 1. All right, so here we're going to have the limit as x approaches 1 of the f function, so that's going to be a 1. The limit as x approaches 1 of g of x, so as I approach 1, what happens? That does not exist. So since one of these does not exist, the whole thing cannot exist here. So this whole thing does not exist. All right, so what about this one? Limit as x approaches 0 of the f function divided by the g function. So my f of x, so we're 0 here, 0. And then g of x at 0 is going to be a 2. So 0 divided by 2 is 2. I mean 0. Good. Okay. All right, what about this one? Limit as x approaches 2 of f of x times g of x. So what's the limit of f of x here? As I'm approaching 2, so that's just what, 2. Limit as x approaches 2 of g of x is going to be a negative 3, so that's going to be a negative 6. All right, so what about this one? Limit as x approaches negative 1 of x times g of x. So since it's multiplication, so I'll do direct substitution right here. So the limit as x approaches negative 1 of x, so that's going to be a negative 1. The limit as x approaches negative 1 of g of x, so negative 1, so it's a positive 1. So when I multiply those two things together, it gives me a negative 1. All right, so this is a composition of functions. So there is a square root. So I can take the limit as x approaches 3 of that f function. So the limit as x approaches 3 of the f function, which is a 3. So then I can just take the square root of 3 plus the 13. So it's going to be the square root of a 16, which is a 4. Okay. All right, what about here? So the limit as x approaches 0 of cosine of f of x. So it's a composition of functions. So I can take the limit of the inside function and then plug that into the cosine function. So the limit as x approaches 0 of f of x. So that is going to be a 0. So then I'm going to evaluate cosine of 0, which is just a 1. All right, here. The limit as x approaches 0 of e raised to the g of x, composition of function. So I'll take the limit of the inside function. So the limit as x approaches 0 of g of x. So as it approaches, that's what, a 2. So this will just be e squared. All right. I hope that makes sense. If you have any questions, let me know.